Welcome to the Empower Apps show. My name is Leo Dion. I'm your host of this show. I run Bright Digit, a Swift development shop. I do iOS development, watch development, as well as our subject for today, server-side Swift. Before we get into that, I encourage you to share the podcast with others on social media and, of course, subscribe. I'd like to hear any feedback or any questions that you have for future episodes. Please let me know. You can reach me, leo@brightdigit.com. And as we get started, I'm going to introduce our guest, Tim Condon. Hey, Tim, how you doing?
I'm great, thanks, Leo. How are you?
Good. What do you do?
So I'm basically an independent freelance developer working solely in server-side Swift these days. So I work with various clients, building stuff for them. I also do consultancy work, so going into companies or having people come to me to teach them best practices of server-side Swift. And I run training courses teaching companies and primarily iOS teams server-side Swift and how to start, how to get going and how to get started.
I feel like the whole backend is kind of a conundrum to a surprisingly large amount of iOS developers. And it seems like server-side Swift might be a great bridge to get a lot of people who just focus on the front end and are just trying to set up their UI table view. Like that, getting that back end stuff, getting good understanding of it and getting started with it, I think is super important. But also I know a lot of managers and CTOs have a hard time deciding what back end to go with. We did a whole episode. I had my colleague Eric on and we talked about some of the headaches he ran into with Firebase, for instance.
Mm-hmm.
And so I think this is a great topic to talk about. And I'm, as we've talked about offline, I'm a big fan of Vapor. And I've had experience doing .NET, Node.js, but going with Vapor was super easy and it was a great fit getting started. How did you get started with server-side Swift?
So I've been involved with server-side Swift since basically the beginning. I read Logan Wright's blog post on Vapor, and Logan's one of the co-founders of Vapor way back when February or March 2016 time. And this is just after Swift had been open source, so it was available on Linux and all these frameworks started coming out. So I started looking into server-side Swift and having a little bit of a play around with it. And then towards the end of that year, I had some free time on my hands and I thought, I want to get in properly. I've been writing a lot of languages at that point, lots of different languages, and really enjoyed Swift. So I thought I'm going to port one of my websites over to Swift. It had a blog, obviously. So I thought, right, I need to write a blogging engine. How hard can it be? Several months later, I emerged from my little hole with a fairly full-featured blogging engine called Steampress.
Nice.
And back in those days, so we're talking very, very early Vapor 1 days, or maybe even before Vapor 1 was out, there weren't many kind of examples of how to use server-side Swift or Vapor anyway. And it was quite a large project. It kind of touched almost every part of Vapor. And it kind of became a bit of a de facto project for pointing people to how do I do this or how do I do that. And so that's kind of how I started to get involved in the community. And it just grew from there. After that, I then started writing for raywendlet.com. And I did a video series on Vapor and I wrote the book on Vapor with the Vapor core team. And then it's just taken off from there. And now I'm got to the point where I'm so busy doing server-side Swift stuff that I've now gone full-time doing server-side Swift.
Awesome. How would you introduce someone, I guess, to Vapor who's already familiar with Node, for instance, which I feel like is one of the big ones out there right now, or PHP or Ruby? What have you seen as the best introduction when it comes to Vapor?
It's essentially the same as kind of Node.js or Ruby on Rails or kind of any of the other frameworks out there. And it does the same job. It provides a really nice kind of platform for building APIs, backends, server applications, even kind of web applications as well, for doing anything you want on the server. So it's a very similar mindset. And it's exactly the same thing as if you're going to write something in Node.js or .NET, ASP, for instance. So it's kind of, that's how you compare it and that's how you introduce it. It's just Node.js, but in another language and better, from my point of view at least. So you have this platform, but you're using Swift, which is, as we all know, it's a very good language. It's growing quickly. It's very popular. It's also type safe. It's kind of statically typed and strongly typed, which allows you to kind of write code that you know basically can't break in most circumstances. So you know that, for instance, if you have something that's not optional, it's never going to be optional. Whereas in some of the other languages, things might be there and they might not. You kind of have to check it at runtime. It's a lot safer with language anyway.
So a lot of people who write Swift, they're familiar with developing in Xcode and deploying an app to like the simulator or the app store, or just running it natively on the Mac if it's a Mac app. How is that dynamic different when it comes to writing a server-side app? Because we're talking about, okay, how do you write an Xcode and then post it to like a server you have set up in the cloud? How does that typically work? Because you're not using it on an actual client device. It's actually being posted to a server. So there's some dynamics that are different there.
Yeah, definitely. So from a kind of development point of view, it's very similar, in fact, to writing an iOS app or even a Mac app. You develop an Xcode, you write all your code in Xcode, you build and run an Xcode, you can debug an Xcode. And so all of that's very much the same, especially now that Xcode 11 has proper Swift package manager support. When it comes to deploying, obviously things get a little bit different because there's no app store for server-side Swift apps. You kind of have to find a solution that works for you. So there are a number of different solutions depending on how involved you want to be. There are kind of platform as a service offerings from Heroku and Vapor Cloud, where you can kind of write a single line of code and you tell it how, you give it a template to build your project, and it will go away, build your project and put it on the internet somewhere for you to use. Or you can just host it on AWS or Google Cloud Platform or Azure or anything like that. And then so you kind of have to be a bit more involved in that way. But once you kind of have a pipeline set up for doing that, then it's actually a lot easier than building iOS and macOS apps for the most part, because there's no app store review.
Right.
You can push code straight away and you don't have to worry about it going through review. You don't know when it's going to, you know that when you push your code, it's going to be there straight away.
Yeah, I found it surprisingly not that difficult to get started with like Heroku, or even it's a little bit more work getting it on a cloud VM. But I'll post a link to my tutorial, which shows you how to just get started and get posted to Heroku and like using a Postgres database or whatever. It was actually pretty easy. And there's a great, what the Heroku has like build packs. It's actually not that bad. I was surprised.
Yeah, it's actually pretty easy.
Yeah, once you get it going, it's not that bad, because at least we have a build pack for on Heroku to get that started and help folks.
Yep.
So a lot of people, when they get started with an iOS app, I know the answer to this, but I want to get your perspective on it. But like, they want to use like a cloud service, like Firebase especially is the big one out there. And we talked on the last episode just some of the headaches that Eric had run into with Firebase. It's easy to get started, but then after a while, it ends up being like a big challenge to really do complex queries, complex models, things like that. What have you found are some of the challenges with like using a cloud service like that, as opposed to just having your own like server side code essentially running?
Yes, the big problem with cloud solutions like that, like CloudKit or Firebase or any of the others out there, they're very opinionated in how you should do things. So if you want to try and do something that's kind of against the norm or a bit out there or isn't supported, you're going to really, really struggle to write some code or at least make it work. And so you end up having to put in loads of hacks to make it work. And then it's kind of just, it really starts to grate and slow you down. And the other problem with things like Firebase as well is that you tend to duplicate a lot of your business logic in the clients. So because Firebase, you can kind of store your stuff and you perform your queries, but you kind of do all those queries on the device or on your client. It means that if you have an iOS app and an Android app, you end up having to do those queries on both devices and you have duplicated code. Whereas if you can kind of do it all yourself, you can put it all on the server and you have a single place where you write that code. So it allows you to change things a lot easier. You have a single place, so you're not duplicating code where you can duplicate bugs and stuff like that. And it just allows you a lot more freedom. So if you want to do anything and everything, you can, because you control the kind of full stack. Whereas with things like Firebase, if you want to do something against the norm, then you're probably going to have a bad time.
What database do you typically work with?
It depends on the client, but for the most part, it's generally Postgres.
Yeah, okay.
I do a lot of stuff with Redis as well, especially for kind of doing high performance stuff. So doing things like storing tokens and things that need to be retrieved quickly.
Right.
And also do a bit of work with DynamoDB as well, depending on, it all depends on the client really.
Right. I feel like just that SQL-based database is still, which has been around for I don't know how many years, but it seems like it's
decades.
Yeah, right. I feel like I lived through the NoSQL phase, and I think there's a use case for it, but it's much rarer than that trend tried to push. And I always feel like in the end, just having a relational database is so handy and so keeps your code so easily organized. And it's the reason why it's been around so long. Whereas like a lot of these highly opinionated cloud services like Firebase or CloudKit, they're much more like document based or even key value based, which like you said, basically takes all of your business logic and it offloads it to your client. And like you said, we've done a whole episode on cross-platform development. Like one of the big things is like if you can keep your business logic unified on both Android and iOS and then offload it onto the server, that's like the best option you have as far as like keeping your code much more simple and much more unified on both devices.
Yeah, definitely. I mean, when kind of things like MongoDB first started coming out, there was a big kind of push to let's shove everything in MongoDB. And what mostly happened was that people started writing relational queries in MongoDB, which is NoSQL.
Your map reduces. Yeah, exactly. Yeah, it made sense because you could see how that use case works when you're a massive company where you have to deal with scalability, but like 99% of folks out there don't have to deal with those issues.
Yeah, I mean, there's definitely a use case for NoSQL databases, but I would say at least 75% of use cases are better off using some sort of structured database.
How would you compare, or what are the benefits you'd say to like server-side Swift or Vapor as opposed to like Node.js or Ruby or PHP or .NET?
So it depends on which kind of side you're coming from. So if you're an iOS developer and you need a backend, these days there is no point having to go and learn another language just to write a backend so you can use. So if you can use the same language you use on your client, which is Swift, then why not? It saves you kind of having to learn a whole other paradigm of language kind of nuances. Even though some of the languages might be very similar, like Kotlin, they all have their own kind of weird intricacies that you have to learn and get used to. If you can use the same language, your learning curve for getting started and building those APIs is going to be a lot quicker. If you're coming from, say, another angle, say you're a Java developer or a Node.js developer or a Ruby developer or a PHP developer, then you might be kind of reaching the point where you're seeing limitations in the language, I'd say. So especially things like PHP, they've been around for a really long time and they're great languages. Don't get me wrong. I mean, they serve a great purpose and they've done really well over the years. But they have a lot of problems and people know about them. And there's all these kind of frameworks and tooling built on top, such as TypeScript or kind of some of the modern PHP stuff to kind of almost shoehorn modern type safety or modern features into the language. But you're always going to have at this point where it's very easy to write unsafe code. Whereas with things like Swift and kind of strongly typed languages, it's a lot easier to write safe code. And there's also things like performance benefits as well. So if you're writing a PHP application or a Java application, you're going to need tons and tons of memory. We all know how much memory it takes to run Slack and another Electron app on your computer. You're talking gigabytes of memory.
Right.
Whereas things like Swift, because it's a compiled language, your memory footprint is really, really small. It's very similar to something like Go in that respect because it's such a small memory footprint. So in these kind of modern ecosystems where you're building kind of say hundreds or even thousands of microservices, if you're going to deploy these all onto kind of several or hundreds of say EC2 instances or servers or stuff like that, if your memory footprint's really small, then it's a lot easier to put more of them on the same server and that reduces your costs. Whereas if you're kind of doing lots of say hundreds and hundreds of JVMs, they're all going to need huge amounts of memory. So there's a big cost benefit that way.
Yeah, I never thought about it that way as far as like the memory usage. To me, I've always thought like if you already have a team of Swift developers, I think Vapor and server-side Swift makes total sense. I think where it might be a challenge is if you already have a team of Ruby developers or PHP developers or etc. Like you have a dedicated server team.
Yeah.
I think like if they're already comfortable with what they do, I wouldn't necessarily encourage them to like make a full pivot. Unless, like you said, they've run into issues where it's like memory or just the language limitations and the headaches of that. It might not be worthwhile necessarily to go with server-side Swift. But I think for like a lot of folks, especially if you're already pretty fluent when it comes to Swift and you like the language, it is extremely comfortable to like do server-side Swift and Vapor. It makes complete sense, but it also stays within the confines of what makes that language so great.
Yeah, I think if you're an iOS developer writing a backend, then you should probably choose Swift by default. We're at the stage now where it doesn't make sense to choose another language unless you have a reason not to. I think we're also starting to see developers from other languages come towards Swift because of its benefits outright. So I run the ServerSide.Swift conference, and they were Java developers who started using Swift on the server for its benefits because it's highly performant, highly scalable, and very efficient. So it's great to see kind of those people come across as well now.
I feel like Java is the perfect language to get people to switch. And I've heard that several other folks who are Java server-side developers have jumped onto the Swift bandwagon because there's been issues with Java as a language anyways, and it makes complete sense.
Yeah, I mean, the language is relatively similar in that you're not going to feel too lost. And then you don't have a JVM. So you've got these huge performance benefits from dropping down to a better language effectively.
So how would you compare the different server-side Swift options out there as far as like Katura or Perfect? I'm trying to think what else is out there.
So in terms of server-side Swift options, you've got Katura, as you said. There's Perfect. There's Smoke from Amazon. There's a couple of other smaller ones as well that are kind of written by other people. And these days, generally, they're all relatively quite similar. So they all are built on top of Swift Neo. So Swift Neo is a non-blocking event-driven I/O framework written by Apple. It's completely open sourced. It's part of the Swift team offering for Swift on the server. And it handles all of the low-level heavy lifting stuff for writing server applications. So it's doing things like HTTP parsing. It's interacting with the kernel, sending data out, receiving data in on the sockets and stuff like that. So you don't have to worry about any of that. So it does all of the kind of really low-level stuff. And then on top of that, you have these different frameworks, such as Vapor, such as Katura, such as Smoke, which provide an API for you to write server applications for. So in terms of choosing between them, it's generally just a case of preference. So they are very different frameworks. They have different opinions how things should be done. They have different opinions on how you should write your code. And generally, it's just personal preference. So for me, I chose Vapor partly because I liked the way the APIs were written and also because the community was so good. Whereas other people, say, might want more of a kind of enterprise support or enterprise backing or focus on enterprise software, and you might choose Katura because it's written by IBM and has a heavy focus on the enterprise. But I would say to people who want to try out Swift on the server, try out as many frameworks as you can, see what works for you and what you like, and then start off with that.
Yeah, I kind of agree. Like, I found Katura to be enterprise heavy, and there's a lot of great reasons why you would want to go with that in the enterprise world. I found Vapor to be closest to what I was familiar with when it came to like a Node.js. I found it to be an open source community similar to Node.js, and the fact that like you could pretty much find a package for nearly everything. Whereas with Katura, it's very much about like monitoring, and I couldn't necessarily find the things that I needed that I was more familiar with, if that makes sense.
Yeah. And so I think there's the Swift server working group, which I'm sure we'll come on to in a bit. But their focus at the moment over kind of the next year or so is to build a solid package ecosystem for Swift on the server. So the idea is that all these packages that were written for Vapor or written for Katura or written for Perfect, that people will then change them so they're written for Swift Neo instead. So you'll write your kind of Postgres database driver for Swift Neo, or you'll write your APNS library for Swift Neo. And then because they target Swift Neo, it means anyone can use them no matter what framework they're building. And so this should help drive a big adoption in packages and kind of build the ecosystem to the point where there's a package for everything, but it doesn't matter what framework you use. So I think that'll be really good to see.
So it sounds like what you're saying is we're not going to have like plugins or packages for Vapor. It's going to be plugins and packages for Swift Neo, which is then going to work on Vapor as well as Katura or Perfect or Smoke.
Yeah, I think there'll be a mixture. So if there's something that's very kind of heavily built on top of Vapor and relies on lots of the packages of Vapor, then obviously it's only going to work with Vapor, and that's fine. But it's kind of some of the more generic stuff that apply to everything, most of them will probably move towards being built on top of Swift Neo, and then that allows you to use them on whatever framework you're using.
Okay. So if somebody were to ask you, is Vapor production ready, what would you say?
I would say yes. I've worked with enough clients and seen enough examples of it being used in production for me to believe it's production ready. And it's not to say that everything's perfectly rosy and there's no problems whatsoever. Sure, there are some issues, certainly with debugging on Linux. There's some weird edge cases you might hit if you're doing some really specialized stuff. But for the most part, I'd say that Vapor is definitely production ready and Swift is definitely production ready.
Yeah, I would definitely say Swift is production ready. And like I said, it's really easy to get started and get deployed. And I think that's a big thing is like the deployment, the DevOps of server-side Swift is actually pretty decent and pretty sophisticated compared to a lot of stuff out there.
Yeah, I mean, these days building server applications, you just build a Docker container, push it up, and then something runs it. That's generally how things tend to work for the most part.
What are some considerations that a development team should make if they're going to go with like Vapor for their backend?
I would say, so it depends on kind of what experience they have of building backends first. So if they're a experienced backend team or they have their own DevOps team who can kind of help them along the way, then for the most part, you can generally just start building and make sure that it all works. And if you're coming from the iOS world, you have to change the way you write stuff a little bit because you're not writing for one user now, you're writing for 1,000 users or 10,000 users or 100,000 users all at the same time. So you can't use singletons, you can't use magic blocks of code that store stuff centrally, because if you say, for example, store the currently logged in user as a singleton, then every person who sends a request to your server will be that user. So there's definitely some changes you have to make from that way. But for the most part, if you have an experienced DevOps team or you have some experiences doing DevOps, then it's not going to make too much difference for you because it's just another web application. If you're an iOS team who's never done any backend stuff before, then you really have to kind of consider, how are you going to deploy your code? How are you going to monitor it? How are you going to make sure it stays up? How are you going to make sure it comes back if it goes down? And all those kind of things. So that's definitely some considerations to use. And things like if you're running on Heroku, it kind of does all of that for you. If you're running on AWS, there are lots of tools out there to help you do that. So there's definitely considerations there to do that.
Is there a way right now that you can build a server-side Swift app without needing a Mac?
Yeah, definitely. There are people I know who write server-side Swift code without using Macs at all. It's all done on Linux. So with the kind of introduction of the SourceKit LSP project, and even before that actually as well, it makes it a lot easier to write Swift code in other editors. So if you're working on Linux, obviously there's no Xcode, but you'll have things like Visual Studio Code or Atom or even Vim. And there are plugins that you can get that will help make your Swift code easy to use. It gives you auto-completion. It gives you type checking, so it underlines where your bugs are and stuff like that. And that's a way of writing your Swift code without using Xcode. And then you can just use the command line tools to build and run your application. So it's Swift build or Swift test or Swift run. And that's how you build, run, and test your application. So if you don't have a Mac, you can definitely start writing server-side Swift code now.
How about on Windows?
Windows is a little bit more complicated. There are people who are doing it. For the most part, they tend to write their code on Windows, but build in Docker containers or kind of do like building remotely. But there is a lot of work. So there's a guy called Salim who is spending a huge amount of time making Swift viable on Windows. So it's kind of part of the Swift open source language project is making sure that Swift and Foundation work on Windows. I think most of it now works and is fairly stable, but obviously there's a lot of code there that needs to be checked and tested.
So Tim, what's the best way someone can get started doing server-side Swift development specifically in Vapor?
So I think all of the frameworks, but Vapor especially, they have lots of documentation on how to get started. There are plenty of blog posts now on people have written to help you get started, tutorials, etc. And some shameless plugs. There's a video course and book, obviously, that I've written and done on raywenderlich.com that takes you from nothing to building kind of relatively massive applications in server-side Swift. But the best way to do is go onto the documentation for each framework and find the getting started page, and that will kind of help you build a hello world application. And then you can start from there. You can, if you want to start interacting with the database, you can follow the docs or find tutorials for that. If you want to send and receive JSON data, you can follow the documentation for that, etc. There's a lot of stuff out there now to kind of help you, not like the early days where you are digging through source code trying to find something that looks like what you're trying to do. And even Stack Overflow as well, actually.
Yeah, I've also found that the Vapor command line tool is actually pretty sophisticated at getting started and getting things installed. And then along with like the Swift package manager, which has evolved to a pretty sophisticated tool, it's made it a lot easier to get started with building an application and getting going, it seems like.
Yeah, I think the Vapor toolbox, which is the command line tool, is a very handy Vapor new command that uses a template that allows you to kind of create an empty project that you can start with. And it also, when you install the Vapor toolbox, it installs all the dependencies you need on macOS to build and run Vapor applications. And Swift Package Manager now it's integrated properly into Xcode 11, if you need to add new dependencies or new packages, it makes it really, really easy. It's a lot better than the old days.
What are some of the components or like frameworks within Vapor that you think are highlights of getting started? Like, for instance, getting your database set up, that I assume is pretty common as far as getting going with getting an API working.
Mm-hmm. Yes. So for getting started with a database, so Vapor has a library called Fluent, which is its kind of ORM or object relational mapping tool. And this basically handles all of the interactions with the database for you. So with some other frameworks, you might find that you end up writing a lot of raw SQL code, which is obviously very unsafe. It's easy to make mistakes or typos. Whereas Fluent handles this all for you. So you just write very simple Swift code to interact with the database. And it also has support for migration, so setting up the database and creating tables, etc. That's all done within Fluent, and it makes it really, really easy to get going, get started. You obviously need a database running on your machine to be able to create tables, etc. But with the advent of Docker these days, a single command line can make running a database really, really simple locally. So with a mixture of Docker and Fluent, you can get going in kind of minutes. I've done plenty of talks at conferences. One of the talks I used to give back in the early days was kind of, here's a 10-minute demo of getting started with Vapor. And I basically built a CRUD REST API in 10 minutes for writing reminders or to-dos or something.
The good old to-do demo.
Yeah, the good old to-do demo like everyone else.
It's like step 2 after Hello World.
Yeah, it is, isn't it? Yeah. So I've done, there are plenty of videos on YouTube, and I can take you through in 10 minutes of how to build a REST API where you send and receive JSON and you interact with the database. And it will show you how easy it is to get going.
And I love I don't know if you'd call it convention over configuration, but I love how you can get 80% of things working fairly simply. It's only when you have like slightly more complicated things, especially like relationships, or you want to set up specific indexes or keys. But it's not hard to do that customization. But Vapor gives you that ability to take your customization further and further. Like, for instance, I had to set up a special a function because I needed to ignore case and I don't know what it's called. I'm not a linguistic person. Like tildes and all sorts of different things that you could have on top of a character. So like I had to set up a Postgres function. I was able to do that within Vapor pretty easily and also use that function in my code. But then if I didn't need that, it was also fairly easy just to get away with the very basic migration that's built into Fluent.
Yeah, I think Vapor is very similar to Swift in many respects. And one of those is that it's very easy to write simple code and very easy to get going quickly. But if you need access to powerful functions or powerful utilities, you can drop down to those low levels and use them. So if you need to write raw SQL queries, that support is still there. So you can write a raw SQL query because sometimes Fluent just can't do what you're trying to do because you might be writing a really complex query with lots of default types, or you're kind of copying columns across, and you can just use raw SQL for that and then use Fluent to decode the result back into a Swift object, and you're back in Swift land. So it gives you the access to write powerful stuff if you need. But for the most part, a lot of it's very simple.
And another thing when it comes to that database stuff, like that I found, is dealing with relationships. I did a whole talk about this in Toronto over the summer. And I found it fairly easy to get going and get my relationships set up and doing queries that way using Fluent and working within that framework.
Yeah, so Fluent's got built-in support for doing parent-child relationships or sibling relationships. So it's one-to-one or one-to-many and many-to-many relationships. And it provides convenient functions and kind of syntactic sugar so that you can just write, it could be users.todos.get, and then you have all the to-dos for that user, which makes it really, really easy to kind of get going and build more complex APIs without having to write complicated code. So
what are some other frameworks that you think are important when it comes to getting started, or that people commonly use when they're using Vapor?
So the other big one at the moment is the authentication framework. So most APIs, you're right, you want to authenticate them with users. So you don't want to allow anyone access to your APIs. So Vapor has an authentication library that has support for doing HTTP basic authentication and bearer authentication using tokens. And it has lots of kind of really helpful syntactic sugar and middleware for easily getting going so that you can add a few lines of code to your user model and create a token model, and then you can just link up and provide a middleware to your routes so that only authenticated users can get through. And then that's all you have to do. And it does it all for you. So you're not writing lots and lots of code to kind of make sure that you have a token there, you then convert that token into a user ID, and then you convert the user ID into a full user, etc. All that's handled by the framework. So that's another really nice part of Vapor when you're doing authentication. Doing things like decoding and encoding JSON is also really useful. That's built right into Vapor. So Vapor 3 requires Swift 4.1, I think it was, or maybe 4. I think it's 4.1. And it makes heavy use of Codable. So in Vapor, Codable is everywhere. So if you're touching the database, you use Codable. If you're touching Leaf, which is its templating engine, you use Codable. If you're sending and receiving JSON, you use Codable. So many people remember the early days of Swift having to manually decode JSON from an API, and it was painful, really painful.
Yes.
Yes, it was. And then in Swift 4, kind of this thing called Codable came along, and all of a sudden you wrote a structure that looked like the JSON you're getting in a single line of code. You had it converted from this horrible string into a Swift object. And so Vapor kind of embraces that fully. If you're sending and receiving JSON, it's really easy to do that in Vapor. And there's lots of syntactic sugar and helper functions to be able to do that for you. So that's definitely another helpful part of Vapor.
Before we get more into sharing code, because I want to talk a little bit more about Codable and sharing code between an iOS app and server-side, I wanted to see if you had ever done any work when it comes to Leaf, because that's the one thing I wouldn't say I necessarily avoid, but a lot of my applications, I just have a basic like REST API that works with a database and has authentication. But I don't do a lot of like HTML templating. Have you worked with Leaf before?
Yeah, so I've actually done a client project that's basically purely Leaf. It was basically pulling results from an API and just rendering them in their Leaf template. So I've done lots of work with Leaf.
So what are some of the advantages or highlights of Leaf? So Leaf is the HTML templating engine for building HTML pages, essentially. A lot of what I've done is just single page applications. So all I'm doing is giving out JSON that gets rendered using JavaScript. I haven't done a lot of like stuff that's just basically rendering out HTML pages, not in a while. What are some of the advantages of going with Leaf, or what are some of the highlights of Leaf?
So Leaf's an interesting one. So I personally absolutely love Leaf. I think it's fantastic. I know there are a lot of mixed opinions about it. So one of the main issues with it is that you're kind of writing HTML and it's not very strongly typed. So it's easy to make a typo and then you've kind of broken your whole template. And it's like writing PHP back in the early days where you get weird errors and you have just a blank page. So there's a lot of kind of mixed feelings, and people kind of want to move towards some of the new function builder stuff and using DSL to render HTML instead. But for its part, Leaf is really good. So it can handle things like futures. So if you provide a future array, it can resolve those futures inside Leaf, and then you kind of get your resolved futures on the other side. You can embed lots of different templates inside other templates. So if, for example, you're writing a web application that has several pages and you have a navigation view, you don't want to write that navigation view in all the different pages, because if you add a new page, that navigation, then you have to change it in 10 different places. So Leaf allows you to kind of extract all that navigation bar out into a template, which you can then inject into all the other pages. That's the big reason behind it. And then it also allows you to do things like for loops with variables that you pass in. So if you're writing a to-do application, I might as well go back to that one. You don't know all the to-dos when you're writing your HTML. So you have to have a way of being able to kind of loop through all the to-dos that might possibly be in the database. So Leaf allows you to do that really easily. So you can get all your to-dos in Vapor and then pass them to Leaf. And then inside Leaf, you can loop through the array and say, for instance, add each to-do as a line in the table. And so it has complex expressions doing for loops. And they look relatively similar to Swift. You can do if statements. You can write your own custom tags as well. So I have one that converts Markdown into HTML. So it's just basically pass the variable into Markdown, into the Markdown tag. So you basically pass the Markdown tag, the variable that contains all of the Markdown, and it just renders the HTML for you. So there are lots of really cool aspects with Leaf. And another part where it's used is when generating HTML form. Another place where it's used is generating HTML emails. So most modern web applications these days generally tend to be JavaScript. So you probably won't use Leaf because you'll just render a very simple HTML page with loads of JavaScript, say using Vue or React or whatever, and then it builds all of that and calls your APIs. And that's a kind of a modern way of doing it because it provides a nice user experience rather than have to reload the page for everything. But you still have to send HTML emails, or you still have to send emails that are written in HTML for the most part, because you can't render loads of JavaScript in those. So Leaf is used a lot by people for generating HTML emails to send out to customers.
That makes total sense. I hadn't thought of that. I'm lazy. I just do plain text emails. But that that makes total sense then. Yeah, that'd be a great use case is sending out emails because I'll use an API like Mailgun to send out sign up emails and things like that. And if I could actually write it out in HTML, that works out great.
Yeah, so there's nothing stopping you from rendering the HTML and then into a string, which you then pass to MailChimp or SendGrid or something to then send the email for you.
Right. Yeah, totally. Any other components or frameworks you want to highlight as part of Vapor?
I think for actual kind of core Vapor frameworks, there are lots of other highlights that people will touch upon. So there's a really nice JWT library for doing JSON Web Tokens. It now supports JWKS, which is JSON Web Keys. I think that's what it stands for. But it means that you can integrate sign-in with Apple in 3 lines of code.
Nice.
If you need to verify a JWT token from Apple.
I could probably do a whole episode on sign-in with Apple, all the headaches that I've heard about getting that working.
Yeah, so I did it for a client a couple of weeks ago. And then one of the clients I'm currently working for, they also would like it for their app. And it's 3 lines of code to just verify the JWT token, make sure it's valid and came from Apple. And then you have your user. It's fantastic. So yeah, there are lots and lots of packages and frameworks inside Vapor. Vapor's taken the approach that it wants to be very modular. Everything's protocol orientated, so there's not a single subclass in Vapor. And it means there are lots of packages that you can easily override or extend or switch out, which makes it a really nice framework to develop on.
Yeah, and one package I wanted to mention, because I've been working with it, is WebSockets. With that app, we had been talking about Hard Twitch. But with that app, I have a Vapor WebSocket that basically sends the updates for health stats over to an HTML page. And it's just plain old JavaScript that changes the heart rate on the web page screen. And that was actually fairly easy to get working, get started.
Mm-hmm. Yeah.
Unfortunately, the Apple Watch doesn't support WebSockets.
Oh, no.
Yeah, so I end up just doing a put request. But as far as actually updating the web page, pushing out updates through the WebSocket, that works fantastically.
Yeah, WebSockets are really useful and they're actually quite simple to use. And I think most of Vapor's stuff is actually just built on top of Neo's WebSockets.
Right.
There's not a lot there otherwise. I'm just having a look through the documentation site to see what other packages I've missed that I use a lot. I think that's it,
Yeah, I think that's it, though. I think it's the security, the database, and HTML rendering, I think, are the big ones. And you've pretty much covered those for sure.
Awesome.
So one thing I think a lot of people are going to ask, and a lot of managers especially want to know about, is sharing code between the client and the server. Are there ways you can do that as far as Vapor and an iOS app? And what are the best ways to do that? Because we had just talked about Codable, for instance. Codable is a big part of that. And I like that it's structured around protocols because it allows for easily implementing it through extensions or various other ways to have a struct or class implement both the server-side component, but also the client-side component as well. So with Codable, you could take a class and have it be a model, which already implements Codable on the server, but then you can use a preprocessor directive or something like that to where only on the iOS app, it looks as if it's Codable only as opposed to the model, which it's not familiar with since model is a server-side component.
Yeah, I've actually talked about this at a conference a few weeks ago, but for the most part, it's very easy to share models, especially. I'm not sure there's much scope in sharing other code outside of models because you generally don't want to put any business logic in both the server-side app and the iOS app, but if you can, it's very easy to do. So essentially what you do is you create a central package. So let's call it To-Do Kit or To-Do Core, because this holds all of your shared code between iOS and the server. And then you create that as a Swift package. And then you can just integrate it into your iOS app using Swift Package Manager, and then integrate it into your server-side app using Swift Package Manager. Because now Swift Package Manager supports iOS, finally.
Yes.
Yes, finally. And for instance, with sharing models, as long as the base model conforms to Codable in the shared package, then on the iOS side, you generally don't do anything to it. You can just use that model to decode or encode your data with JSON encoder and decoder. But then on the server-side world, you can either make it conform to your database model. So that could be like a Postgres model. And then you can then use that model to save in the database or perform queries. Or for most real apps, what you'll tend to do is you'll have kind of an adapter layer between your public representation of the model and your model that gets saved in the database. So for instance, in the database, you might have user passwords, you might have date formats, you might have properties that you don't want sharing. And then on the model side, you might want some computer properties that make it easier for the user to consume that API. And so you just have like kind of a little adaptation there between the two. So you have a kind of user model that is saved in the database, and then you have a user public model that you send over your API. And then you just convert between the two. And then that user public model is then shared between iOS and the server. And then it makes it really easy at that point to share code, because at that point you're sharing the code. So at that point you have the same code on both the iOS and the server, and both the iOS and the server are using JSON encoder and decoder. So you really don't care at that point what it looks like over the wire. So if you're sending it over the network, you don't care what your JSON looks like, because it's the same encoder and decoder on both ends.
Exactly.
Yeah. So if you're dealing with dates and stuff like that, then all that kind of worry goes away. Whereas before, if you're consuming a external API, you have to worry about what format is this data in, and then have to write a custom date format to make it formatted, etc.
Yeah. And I think we've all written that boilerplate code like 1,000 times because people use a different date encoding than Apple expects.
Mm-hmm.
And we did a whole episode with Abby Jackson about how to organize Xcode projects and workspaces. And like Swift packages have been a big help with Xcode 11. And using a Swift package to keep your data model unified is a great way. I hadn't even thought about that. That's fantastic.
Yeah. And I did a talk about, it must be like March time or so, about sharing code between iOS and server. And at that point, I had to create a shared package that had both the pod spec and the Swift package manager manifest, and basically cram both the bin to make it work. And it was pretty gnarly, to be fair. Whereas when I did it a couple of weeks ago, it's like, just create a Swift package, there you are, done, works on both.
Yeah. Has there been issues as far as, and I've run into this a few times where I've had a Swift package, maybe not my Swift package, but somebody else's, to where Linux expects certain frameworks to be already existing as opposed to like on the Mac or on iOS, the framework or some of the backends, the behind the scenes stuff is done differently?
So there are some intricacies if you're consuming Swift packages on Linux that you won't get when you're consuming on macOS. So for instance, if the Swift package you're using imports UIKit, you obviously can't use that on Linux. Or if you are expecting access to command line tools that so you can just shell out and call a process, you can't do that on Linux. So there are some weird cases where you might be able to use the package on Linux, but for the most part, most of the Swift packages out there are Linux compatible.
And especially when you're talking about creating models and codables, that should not be an issue at all.
Yeah, as long as you're using Foundation, then there's no problem at all.
So I want to ask, what's the future of Vapor, especially Vapor 4? Like, we talked a little bit about the Swift Neo and the ServerSide group. What are some updates that are coming down the line now that I think it's in alpha? Is it alpha or beta right now?
The second beta came out yesterday or day before, I think.
Okay. So what are some ways that Vapor is looking at evolving in Vapor 4?
So Vapor 4 is in heavy development at the moment. The main focuses for Vapor 4 are going to be Swift Neo 2, the Swift Server Working Group work, and Fluent. So currently Vapor 3 built on top of Swift Neo 1, and there's now Swift Neo 2. So there's obviously a bump there. There isn't actually a lot of change of code there. So for the most part, that should be quite easy. The second big change is going to be integrating a lot of the work from the Swift Server Working Group. So over the last kind of 6 to 12 months, the working group have really focused on building some core packages that everyone will need. So things like Swift Log, Swift Metrics, that all apps will use. So in Vapor 4, those are going to be integrated into Vapor itself. So if you're using a logger in your application, then it'll be the same Swift Log throughout your whole application. And then it's the same Swift Log that everyone else is using. So if, say, someone writes a implementation for Swift Log that logs it out to S3, so sends your logs to S3, then that will work no matter what you're writing, because you can just call logger.info or logger.warning, something like that. And then Vapor itself isn't really going to undergo too many heavy changes. There's a few tweaks to routing and stuff, but for the most part, it should be fairly similar, although it will require Swift 5.2, I think, instead of Swift 4. So there's a bump there from the Swift version. The big change for Vapor 4 is going to be in Fluent. So Fluent 3, whilst it was very easy to get going with and very easy to use, it was slightly constrained in its abilities. So you couldn't do things like eager loading relationships in the database. It was very difficult to customize column types. So Fluent 4 is going to be changed quite significantly to allow the focus for kind of the real apps. So you'll still be able to build simple hello world getting started applications with Fluent quite easily. But the real apps that are using Fluent properly, that need to do things like eager loading and lots of different queries, they'll have that power now. So Fluent 4 will be heavily based on property wrappers. So making sure that you're writing type-safe code for doing parent relationships and child relationships, etc. And there's also talk of doing things like function builders for some of the other stuff in Vapor, like Leaf, etc. But Fluent is going to be the big change in Vapor 4. So updating to Swift Neo 2, updating to Swift 5.2, using property wrappers and etc. in Fluent, they're all going to be a big step forward. And I think it's going to be a big step in maturity for Vapor, in that now that everything's using the working group packages, it allows people to build and share code a lot easier.
Yeah, and that's what I've found with Vapor 4 is a lot of stuff from Swift 5.1 that was introduced more or less as a scaffolding for Swift UI, and that is being brought into Vapor 4, like you said, property wrappers and function builders. And that's made Fluent a lot easier to get started and a lot more intuitive when I look at it. I don't know about you.
Yeah, no, it's a lot easier to see. So if you're defining a relationship in Fluent 4, it's a lot easier to see that, oh, this is a parent, rather than before where it's kind of like, oh, here's some random UUID. Is this the parent, or is it a child, or what's it linking to, etc. So there should be a lot of changes that will make it nicer to use and easier to understand what's going on.
Right. Yeah, exactly. And then as far as like Swift UI and Combine, has that influenced some of the thoughts as far as Vapor 4, especially when it comes to like function builders? You just mentioned that in HTML and Leaf.
Yeah, so obviously Swift UI was the reason why property wrappers were introduced. Vapor's definitely jumped on the bandwagon there and is going to implement them heavily throughout the code base. Things like function builders and stuff. I know I've spoken to Tanner a bit about Leaf, and he's quite keen to build a DSL that will replace Leaf and be more based on function builders. But I think that was probably going to wait for Vapor 5, I suspect, or maybe even later on, because for the main reason at the moment that function builders are still semi-private and that they're underscored, so you can't really use them. But I think other things that have affected Vapor, especially, so Swift 5 has brought lots of changes to the underlying language that will provide big benefits to Vapor. So it moved from default string encodings, moved from UTF-16 to UTF-8, because Apple tried to go down the UTF-16 route and then realized the rest of the world had gone down the UTF-8 route, which is fine. But previously, before Swift 5, if you are using strings in Swift and, say, parsing HTML, then you had to convert it from UTF-8 to UTF-16. And so there's a big performance hit there. So by just using a newer version of the language, you end up with it was like a 15-20% performance increase.
Nice.
And then the other big thing that I haven't really mentioned actually is, so Vapor 3 is very asynchronous. It uses Swift Neo's futures and promises throughout the whole code base. And that is a bit of a learning curve to get used to, especially because the compiler can end up producing just weird error messages because it doesn't know what's going on.
Oh, yes, I know this very well.
Yeah, but because Swift UI also uses closures and type inference a lot, it's actually been a kind of heavy exposure of people hitting these problems with weird compiler messages. So I think Swift 5.2 is introducing a new type inference engine that should massively improve these errors, which means that all the kind of asynchronous stuff in Vapor should get a lot better error messages when things go wrong. So that's a nice little side benefit from Swift UI as well.
Yeah, we've talked about the whole asynchronous and futures and how that stuff is sketched out in Vapor. Once you wrap your head around it, it's so much easier than dealing with callbacks and the callback hell that you can deal with Swift. And I really like that. And it's interesting that with like Swift UI, Apple has gone a different route with publishers and subscribers, which I guess kind of makes sense from a reactive standpoint. But for some of the simple stuff you do on the server, like the stuff with HTTP futures and promises, it's really nice. I like how that stuff is structured and set up in Vapor and in Swift Neo.
Yeah, so there's lots to talk about whether Combine will be open sourced. And there's definitely a use case for using it on the server side in some aspects. But I think for most part, the big changes can be when Swift gets a proper concurrency model.
Yes.
So once async await or something like that comes through into Swift, then that will make huge amounts of differences to people using Vapor and Swift.
Yeah, I did a whole talk on asynchronous development and how we've changed a lot from dispatch queues and operation queues now to Combine and promises and futures. And there's not a lot of consistency when it comes to that. So yeah, I am looking forward to that day as well. So before we close out, If you were going to sell someone who's an iOS developer to get going on server-side Swift, how would you sell it to them?
So I would say 50% of the people I talk to, maybe even 75% of the people I talk to who are looking at doing server-side Swift as iOS developers, they all come to me with the same problems and same use case in that their iOS app is now quite complicated and they have to call 12 different APIs just to populate their home screen. So their back-end team, which are based in a different city or a different country, provide an API that they consume, but for them to populate the home screen, they have to make 12 different API calls to get all the information they want. And it makes it really kind of complicated. And there's a lot of messy code in their iOS app to make all these different calls because you have to make an authentication call, you have to make a call to get all the users, you have to make a call to get all the to-dos, you have to get all the relationships for the to-dos, etc. So the biggest kind of selling point that I'm seeing at the moment for Swift on the server is kind of writing backends for front ends. So this is a design pattern that's been around for quite a while, but is kind of seeing more prevalence in Swift at the moment, in that you can write a very small server-side Swift application as an iOS developer that does all these calls for you. So the server-side Swift application makes the 12 different API calls for you and then just vends your iOS app a really simple API that you consume with one call rather than having to make loads of different network requests. So it makes it easier to use from the iOS side because you only have to make one call and you know all the data you're getting up front is there. And it's better if you're working on, say, cellular connections, which might be a bit unstable because the thing that's doing all the network requests is on a server farm somewhere or on a data center with a decent internet connection. And then you only have to make one request that you can retry if it fails rather than retrying 12 requests, if that makes sense.
Yeah.
Definitely, like when I'm speaking to people at conferences or speaking to people at companies, there's definitely the use case I see the most kind of desire behind and interest behind.
Awesome. Tim, it was really great to have you on. I'm a big fan of Vapor, so I'm glad we finally have a guest to talk about how dynamic and how awesome Vapor is when it comes to server-side development. And I hope it continues to grow. And it's awesome, some of the work that the server-side team is doing. So I really appreciate you coming on.
Oh, thanks for having me. It's been great to be on here.
How can people find you online?
The best way is Twitter. I am 0xtim, and that's 0 the number, X as if you're writing hex. That's the best way to find me is through Twitter.
Cool. And we'll have links to your books and videos as well in the show notes.
Excellent.
If people want to get a hold of me, they can find me on Twitter at Leo G. Dion and my company as well at BrightDigit or brightdigit.com. We look forward to talking to you again. Please let me know if you have any feedback or questions for our guests. You can reach me, leo at brightdigit.com. Thanks again, and we will talk to you later.